Azure Firewall is a managed cloud-based network security service provided by Microsoft Azure. Firewalls are classic security controls. They are widely used to separate external networks from internal networks in on-premises environments. Firewalls monitor and filter inbound and outbound. Let's look at Azure Web Application Firewall. Web applications are widely used today. However, they have all kinds of vulnerabilities that attackers can exploit. For example, the Open Web Application Security Project, OWASP, is an international non-profit organization that works to improve application security. OWASP lists top 10 security risks for web applications, such as broken access control, injection, and insecure design. Developers may spend significant time and effort trying to identify and mitigate application vulnerabilities. How can we add another layer of protection for web applications and enable developers to focus more on functionality? One possible solution is to use a Web Application Firewall, or WAF. A WAF is placed between visitors and web apps. It works like a firewall to monitor and filter application requests. A WAF blocks web attacks targeting common application vulnerabilities. It only allows valid requests to interact with web apps. Azure Web Application Firewall provides centralized protection for web apps, so organizations can manage and patch vulnerabilities in one place instead of working on each web application. You can deploy Azure WAF with Azure Application Gateway, Azure Front Door, and Azure Content Delivery Network, or CDN. Azure WAF also helps defend against distributed denial of service (DDoS) attacks targeting applications. Moreover, Azure Web Application Firewall is integrated with Microsoft Security Copilot, an AI-powered assistant for security analysts. You can use prompts to access its capabilities in Microsoft Security Copilot, such as getting details of SQL injection or cross-site script attacks blocked by Azure Web Application Firewall. Let's talk about Azure DDoS protection. First of all, what is DDoS? DDoS stands for Distributed Denial of Service. It's a common type of cyber attack that aims to take down your services. The word distributed indicates the attacks come from multiple sources. For example, in a well-known DDoS attack, hackers used millions of compromised IoT devices to simultaneously send requests to an online service, eventually causing it to shut down. There are some common types of DDoS attacks, including volume-based attacks that send numerous requests to overwhelm network bandwidth, blocking the traffic for legitimate requests. Protocol-based attacks that flood specific protocols at the network and transport layers to disrupt the service. For example, SYN flood or ICMP flood. And resource or application attacks that target the application layer to exhaust the available resources. For example, HTTP flood or SQL injection. Azure DDoS protection specifically addresses the first two types of DDoS attacks at the network and transport layers. This is a diagram from Microsoft that illustrates the role of Azure DDoS protection. It helps organizations protect their services by continuously monitoring network traffic, intelligently tuning the traffic profiling, blocking detected DDoS attacks, and generating alerts. As Azure DDoS protection provides at network and transport layers, to fully cover all types of DDoS attacks, It's recommended to add Azure Web Application Firewall, or WAF, to defend against application layer DDoS attacks. Azure Bastion provides secure access to virtual machines directly from the Azure portal. For example, suppose your organization has virtual machines running in a virtual network within the Azure cloud. Your administrator needs remote access to these virtual machines for maintenance tasks. One common way is to assign a public IP address to each virtual machine. Then the admin uses RDP or SSH protocols to connect to these public IPs. However, it brings two immediate concerns. You need to allocate many public IPs, and you need to loosen your network security rules to allow RDP or SSH access from the internet. This approach would expand the attack surface and increase your workload. This is where Azure Bastion can help. Here's a diagram from Microsoft that illustrates the role of Azure Bastion. Instead of directly connecting to a virtual machine through its public IP, you can first log into the Azure portal. Then access Azure Bastion in your virtual network. From there, you can connect to your target virtual machine through its private IP. By using Azure Bastion, you can achieve seamless secure access to your virtual machines without exposing them to public IP addresses. Now let's do a quick demo of Azure Bastion. Here's my resource group page in the Azure portal. We can see it contains a virtual network and some virtual machines. To access a virtual machine through Azure Bastion, we can click on the virtual machine. Choose Bastion. For this demo, we will simply use a VM password as the authentication type. Enter username and a VM password. Click Connect. Azure Bastion opens a new browser tab. I can now work on my virtual machine there. Azure Key Vault is a cloud service for securely storing and accessing secrets. Why do you need a secrets management solution? Just think about how many user accounts, passwords, and pins you use. Is it easy for you to remember them without a tool? In an enterprise environment, numerous systems and applications rely on various types of secrets, such as passwords, API keys, and digital certificates to verify access, encrypt data, and secure communication. How can you manage these secrets securely and efficiently? This is where Azure Key Vault comes into play. It provides centralized storage for all your secrets within a specific environment. It controls access using various policies. It monitors access activities and performance, and it allows a soft delete to recover from accidental or malicious deletion. You can use Azure Key Vault to store three types of content: keys, such as encryption keys used to encrypt and decrypt your data; secrets, such as passwords, pins, tokens, and any other confidential information; and certificates, such as SSL TLS certificates to secure website communication, email encryption certificates, and your self-signed certificates for internal systems and applications. Now let's do a quick demo of Azure Key Vault. Here's the Azure Key Vault page in the Azure portal. Under Objects, you can manage keys, secrets, and certificates. Click Keys. You can generate or import keys. Click Secrets. Here you can create a secret, giving a name and a secret value. Click Certificates. Here you can generate or import certificates. Cloud computing empowers modern businesses with scalable, agile, and cost-effective services. As more companies move their infrastructure, applications, and data to the cloud, cloud security has become a top concern. Microsoft Defender for Cloud helps organizations improve their overall cloud security posture through its CNAPP capabilities. What is CNAPP? CNAPP stands for Cloud Native Application Protection Platform. It's a unified solution that integrates security and compliance to prevent, detect, and respond to threats across multi-cloud environments. It also enables security throughout the application development lifecycle and protects cloud workloads. Microsoft Defender for Cloud provides a CNAPP solution through three key capabilities. Cloud Security Posture Management, CSPM. Security posture refers to the current security state of an organization. It shows how effectively the organization can defend against threats based on its configurations, policies, and controls. Cloud Workload Protection Platform, CWPP. It protects cloud workloads such as servers, app service, storage, databases, and containers. Development Security Operations, DevSecOps. DevOps is a modern security approach which combines development and operations to enable a continuous integration and a continuous delivery CI/CD pipeline. DevSecOps extends DevOps by embedding security practice into every stage of the process. In addition, Microsoft Defender for Cloud integrates with Microsoft Defender XDR, an extended detection and response suite of products to provide enhanced protection against advanced attacks. Let's take a quick tour of Microsoft Defender for Cloud. On the overview page, you will see a dashboard with information such as security posture, regulatory compliance, workload protections, and inventory. Under Cloud Security, you can manage security posture across multi-cloud environments, manage regulatory compliance, and view recommendations based on industry security benchmarks, apply workload protections, and implement DevOps security. Microsoft Defender for Cloud provides a Cloud Security Posture Management (CSPM) capability. What is a Cloud Security Posture Management? It refers to a set of policies, tools, and processes for assessing, monitoring, and improving the security state of cloud environments. First, you need to select your cloud environments. You can enable Microsoft Defender for Cloud in multiple cloud environments, such as Azure, AWS, and GCP. Then you will create a security initiative that is a collection of policies or rules. Each policy defines a specific security condition you want to control. For example, all virtual machines need to use encrypted disks. You can create custom security initiatives or use pre-built compliance standards. For example, Microsoft Cloud Security Benchmark is a default initiative applied by Microsoft Defender for Cloud. Based on the deployed security initiatives and policies, Microsoft Defender for Cloud provides the visibility into the current security posture of your cloud environments. You can view the Secure Score, which measures the risk level by continuously assessing all findings. You can also get a list of recommendations for improvements. After you complete recommended actions, the results will be reflected in your Secure Score. You can enable various compliance standards in Microsoft Defender for Cloud. For example, Microsoft Cloud Security Benchmark, a set of cloud security best practices, ISO IEC 27001, an international standard for managing information security, PCI DSS, a standard for securing payment card data, NIST SP 800-53, a framework for security and privacy controls in federal systems, NIST SP 800-171, a standard for protecting controlled unclassified information, or SOC Type 2, a standard for securely managing customer data. These standards are pre-built security initiatives for assessing your security posture. Let's do a quick demo of security posture management in Microsoft Defender for Cloud. Under Management, click Environment Settings. Here you can configure your multi-cloud environments. For example, add AWS, GCP, or GitHub environments. Select an environment, for example, Azure Tenant Root Management Group. You can enable a security standard in your environment or create a custom standard. In Microsoft Defender for Cloud, under Cloud Security, click Regulatory Compliance. Here you can view the compliance dashboard. Select a standard, for example, Microsoft Cloud Security Benchmark. You can view all compliance controls and the resource compliance status. Click Security Posture. Here you can view the current Secure Score by cloud environment. For each environment, you can view its recommendations. Click a recommendation. You can view the detailed information and take action to mitigate the threat. If your organization has Microsoft Security Copilot enabled, you can use the AI assistant to summarize this recommendation. Microsoft Defender for Cloud provides a Cloud Workload Protection (CWP) capability. Cloud workloads refer to services, applications, or functions running in the cloud. They are hosted using cloud resources such as servers, app service, databases, storage, containers, Key Vault, Resource Manager, and APIs. Microsoft Defender for Cloud offers a variance of Defender plans for specific resource types. For example, Microsoft Defender for Servers and Microsoft Defender for App Service. These Defender plans provide enhanced security capabilities for workloads, such as endpoint detection and response, vulnerability scanning, threat protection alerts, compliance tracking, access and application control, and security for multi-cloud and hybrid environments. Let's do a quick demo of workload protections in Microsoft Defender for Cloud. Under General, click Get Started. Here you can enable Microsoft Defender for Cloud's enhanced security features. Select your subscription. You can enable various Defender plans for your workloads, such as servers, app service, or databases. Under Cloud Security, click Workload Protections. Here you can view the coverage of your Defender for Cloud. Microsoft Defender for Cloud provides a DevOps security capability. You may ask, what is DevOps? In the traditional software development lifecycle, development and operations are two separate processes. Typically, developers write the code, testers verify the changes, and finally, operators deploy the release packages to the production environment. DevOps is a set of philosophies, tools, and practices that combines the development and operations workflows. It enables a continuous integration and continuous delivery CI/CD pipeline. Here's a diagram from Microsoft that illustrates the continuous DevOps process. It integrates planning, development, delivery, and operations to improve efficiency, collaboration, and quality of software development. On the other side, DevOps brings new challenges to security. How can we embed security into each stage of DevOps process to reduce cyber risk? Microsoft Defender for Cloud offers key functions to secure DevOps, including providing centralized visibility into the security posture across multiple DevOps environments, enhancing configurations of cloud resources, and helping developers prioritize critical code fixes. Let's do a quick demo of DevOps security in Microsoft Defender for Cloud. Under Cloud Security, click DevOps Security. Here you will have a unified view of security posture across multiple DevOps environments. Click Add Environment. You can connect additional DevOps environments. You can see the security findings from each of your DevOps projects. Select a project. You can check the resource health and get recommendations for remediate security issues. Select a recommendation. You can view its details and take the suggested actions. Let's look at the endpoint management and security capabilities provided by Microsoft Intune. You may ask, what is an endpoint? From a security perspective, endpoints are devices that are used as entry points to an organization's on-premises and cloud environments. For example, laptops, desktops, virtual machines, mobile devices like smartphones and tablets. Why is endpoint management and security so important? Because these devices are distributed to a large number of users and may be used in various locations, like employees' homes or airports. They are vulnerable to all kinds of cyber attacks if not properly managed. Once compromised, they can be used as entry points for attackers to penetrate corporate networks. We have discussed the shared responsibility model in cloud computing. It's important to note that customers are always responsible for their own devices when accessing the cloud. So managing and securing endpoints is critical to your overall security posture. This is where Microsoft Intune comes into play. It's a cloud-based endpoint management and security solution that provides the capabilities such as device management, app management, endpoint security, and endpoint analytics. In addition, Microsoft Intune is integrated with Microsoft Security Copilot, an AI-powered security analysis solution. With Security Copilot, you can use prompts to perform common tasks, such as getting device details or summarizing a device policy. Now let's take a quick tour of Microsoft Intune. Here's the Microsoft Intune Admin Center. Under Devices, you can centrally manage your organization's devices across various platforms, including Windows, iOS, macOS, Android, and Linux. Click All Devices. You can view a list of enrolled devices. Select a device. You can explore with Copilot to summarize this device, analyze an error code, or compare this device with another device. You can monitor hardware, discover the apps, device configuration, and many more. Under Apps, you can deploy, update, and protect applications on your devices. Under Endpoint Security, you can configure device security policies and manage security tasks. Click All Devices. You can view the compliance status. Click Security Baselines. You can apply Microsoft recommended security configuration settings to your devices. And you can manage various security controls such as antivirus, disk encryption, and endpoint detection and response. Under Reports, you can monitor the health and activity of your endpoints. Click Endpoint Analytics. You can access reports such as startup performance, application reliability, and work from anywhere score. Let's look at the risk and compliance management capabilities provided by Microsoft Purview. In today's business world,